Our presenters for this topic are Clemence Burnichon, and she is the director. She's the director of data innovation, which is a function inside the Data and Insight group. Clemence has more than 10 years of experience in the AI and data space. And the second presenter of this talk is Lou Franklin. She is a lead infrastructure consultant at Thoughtworks that helps clients to deliver infrastructure and platforms into the cloud. So the stage is yours, I would say.
Well, thank you for the intro. I'll let you. I'm gonna have to say a lot of next slide, please, but we'll work it out. Please, if we can go to the next one. So I'm going to talk to you a little bit about ITV. I know we don't necessarily have only a UK audience. So what is ITV? So at ITV, we create, we own, and we distribute our own content to broadcasters and platforms around the world. When it comes to content, I'll highly recommend Snowpiercer. We might find it on different platform. I'll highly recommend it on ITV. We also create formats like Love Island. So we've got the first version from the UK, but also you will see version in the in the US, in Australia, etc. And we also have contents like Coronation Street, like more sub kind of drama, and we actually hitting milestone with more than 10,000 episodes around that. The other side of our business is next slide, please. Is being a streaming business. So not only we distribute our content on other broadcasters and platforms, but we also distribute our own content on our own channel and on our own platforms. So channel will be ITV, ITV2, etc. And then for a platform, you will have Hub and Hub Plus at the moment, and soon we are launching ITVX by the end of this year. So that's really our business. And as you can imagine, data has a big place in that business. And a couple of years ago, about a year and a half, 2 years ago, we started a new data strategy. And so I'm gonna give you a definition of our data strategy and what we're trying to achieve. If you can go to the next slide. So what is our data strategy? So it's an outcome-based, value-prioritized approach to data through an iterative development of data products in partnership with the business. So a bit of a mouthful. So I'll kind of go through it a little bit. So really, it's outcome-based in the sense that we look at our current situation, we look at the situation we want to be in, and we'll develop whatever is necessary to go from one to another. It is value prioritized because every initiative has a number with a pound sign attached to it that will tell us how much value is going to deliver to the business, and that is one of the main reason of the priority of that item in the roadmaps. And when we talk about partnership with the business, it's all about being embedded with the business and supporting the strategy of every part of the different part of the business. So, you know, marketing, commercial, etc. And all of them will have their own strategy, and we support that by creating and iteratively creating those data products that we need. So to be able to realize that, we decided to go and build a data mesh. So why did we go data mesh? The first one was we wanted data to be as a product rather than data as a service. Often data as a product, it's all about mindset. There's that aspect of value, etc. Versus data as a service, it's more data as a cost center, and you know, doing small things and, you know, giving account of users that have done something versus developing really something that would have a value for the business. The next reason is about empowerment and ownership. We wanted to make sure that every part of the business will feel empowered to use our data and to use our platform. And with the concept of data mesh and having like different domains and fully decentralized team will generate that. well, the next one is actually decentralization, because we realized that it was quite important for the business to have a clear mark on what we wanted to do in data and really make it a partnership. And to do that, we needed to decentralize. And the last one is the one that is probably more dear to my heart than anything else, is about scalable architecture, making sure that, you know, today we can support 3 domains, tomorrow we can support 5, and you know, a year later we can support 20 or 50 if we decide to do so. So it's all about that for the data mesh. So when it comes to what our data mesh, our stack look like, really, it's a very simple and very by default stack. So we have AWS as a layer of infrastructure, and on top of it, as a core data platform, we use Databricks for data engineering, data science, etc. We have a couple of other things around that I'm sure Lou will mention in the following slides that enable us to really realize everything we want to do. But that is kind of our main stack. So I'll let Lou do the heavy lifting on the self-service, and I'll come back to you towards the end.
Oh, thanks. Yeah, so as we were talking about, we've been doing this project around data mesh delivery with ITV. And if we look at data mesh and what data mesh is and how we talk about implementing data mesh, there's 4 key principles, really. Domain ownership, which Clemence was alluding to, the data as a product, so treating data as these self-describing units, self-service data architecture and infrastructure, and federated computational governance. So obviously, we're going to focus a lot on this talk around the self-service part of that data infrastructure. And obviously, it's a key tenet in the principles of data mesh, which is part of why it's so important. But I appreciate that probably on this call, not everybody might be working in the field of data. And I often describe data mesh at a high level as essentially microservices for data. So no matter what world you're working in, I think if you substitute data product for a microservice or something similar, a lot of the same principles can be applied. And in fact, we've taken a lot of principles from kind of microservice worlds in thinking about how we structure the way that those data products are defined and come together as well. And so this is where we wanted to start from. Okay, what is data mesh? What are we trying to do here? Okay, we're trying to create these discrete data products that can be self-describing and self-fulfilling. So the first thing we approached with ITV was around how do we want to structure the data mesh overall? Because this is going to help us work out what our data products need to know about themselves. And there are a number of capabilities, and I'm not going to go through all of the capabilities on this diagram, but there are a number of capabilities that we knew we wanted to develop out over time, over the period of building out the data mesh. And we pulled them into these layers on the right-hand side. And they essentially revolve around the layers of how often a discrete deployment of that component, of that capability exists. So for this, I mean, we have a data platform, which is that kind of second layer up. We deploy that across multiple business domains. And so we give a copy of that, a version of that to each business domain. It's kind of their own little playground. It helps us segregate the kind of blast radius in case things go wrong. And also just kind of allows us to build some ownership boundaries as well and help facilitate how we manage that. All of this is kind of within AWS. So for us, that instance of a data platform also equates to like an AWS account. So every domain is going to have their own. So there is a lot of things that we have in that baseline platform where everybody gets one copy across the whole domain that all data products would then share and be built on top of. And then you get that second layer up from there, where we think about what exists within the data product. What do we have per data product? So what are those capabilities that we really need to focus our self-service around? So things like storage and persistence of data, access to that data, the anomaly detection, things like that, and as we build out into the future as well, and the inputs and outputs of that data. And looking at it in this sort of layered format really has allowed us to work out where do we need to pull the different governance policies as well? Where do we need to automate and federate those governance policies? Where do we need to build in our security, all our best practices, and the facilities that we need in order to have a platform that can scale? So I think Clemence had mentioned, you know, okay, we might have like 20 domains, 100 domains, who knows? On the roadmap at the moment, we have kind of 3 or 4 at the moment. Depends a little bit how you count them. We've got a little bit of a special one. And we have probably about 30 data products. But we've committed to being able to scale, certainly in the immediate future, towards sort of 10 domains. So we know that that's something that at minimum we need to be able to support. And we've kind of committed to being able to support at least 300 data products per domain. So obviously, when you're getting to having 300 of those things on there, we at the moment have one centralized platform, data platform team. To manage all of those, your self-service and your automation are going to be super key to making that successful. And we're a little bit lucky with ITV in that what we built on at that data platform layer, they have something called Common Platform, and Common Platform is very well thought of in the business. It's something that they build out across all of their accounts that all infrastructure is built on top of. So it provides a little unifying layer, something a little bit like that platform utility layer in some respects, with some of the networking and things like that. So we got to enhance and jump on the back of that to help us kind of build up quickly. But obviously that it always comes with its own drawbacks as well. So we've had some fun playing around the different boundaries with that. So let me get on to the data product itself. So what does it mean to be a self-defining data product? When we say data products to a lot of people, particularly business people, the thing they immediately think of is, oh, it's a data set, right? That's my data set, which is really only thinking about the output part of a data product. And what I tend to say to folks is, if you remember nothing else, remember that a data product has 4 pieces to it. It has its input ports, its output ports, which are the most common thought of. It has a transform piece, which is essentially how do you get from your input to your output? And then we have the often neglected control ports. And your control ports are a little bit more ubiquitous, a little bit less difficult, a little bit more difficult to describe. And they are the things I sometimes say that give you the ilities. So your discoverability, auditability, traceability, and those sorts of things. So that's how we kind of plug our data product into the rest of the mesh, how it puts itself out there and to be discoverable, but also how it puts itself out there so that we can govern it and control it in a managed way as well. And so we have a number of different types of input ports that we support at the moment, from queues to other data products, third-party systems. As Clemence was alluding to with Databricks there, a lot of the heavy lifting and compute is generally done through Databricks, with some interaction with Databricks there. But we send a lot of configuration that we do on a per data product basis. And then our output is often S3 tables, sometimes posting things to third-party systems as well. But those are our kind of key components. And as we go through the rest of this, I'm going to keep coming back to those 4 key components. So the other thing that we had when we set up the vision of this, when we sat down in inception, way back at the beginning of the project with Clemence, I drew up a little mock of what we wanted to head towards, which ended up being called and referred to as the magic YAML. It was the thing that was going to solve all of our problems for how we do self-service, how we make these data products happen magically without the people creating them having to have loads of technical knowledge. And what we ended up with is obviously that kind of name stuck. And so we had to come up with an acronym for it. And so our PO and I came up with what we wanted this to be. So our managed attributes for globally defined capabilities, which sounds interesting, I suppose. But as it is, you've got to have an acronym for all of these things. And we came up with a mock-up of what we wanted this magic YAML to look like. And as you can see, it kind of breaks down into those kind of key areas as well. So we've got a little bit of overview of things that we need. Every data product needs a name, needs an owner, needs to belong somewhere. But then we want to talk about it in terms of those 4 key areas. What configuration of those 4 key areas does it have? What input ports, what output ports, what compute types? And the one bit that is sort of missing on here that you won't necessarily see is the control ports. And that's a little bit because we don't really allow people to opt into the control ports. You have to have them most of the time, right? You have to be discoverable, you have to log, you have to be auditable. You don't really get a choice about opting into those things quite so much, which is why you won't see them so much on these breakdowns. So we had our vision, we knew what we wanted to go towards. Now we just had to get there. And we looked a little bit around, like I was saying, it's, you know, data mesh is a little bit like microservices for data, right? So we looked at, if you've ever come across it, the open application model, which is a model for microservices and self-defining microservices and keeping them close. And they have kind of 3 key principles, I suppose, in terms of how they look to design things under that model. One is that you put the application first, you clarify and you make sure that everything you do is extendable, and also you want to be vendor agnostic. Well, we knew that we probably weren't going to be vendor agnostic per se, because we're going to be on AWS, but we do know that we might want to be vendor agnostic when it comes to Databricks or other third-party systems that we plug in and out of. We know that we need to be extendable because our data products could at any time require more features that we need to be able to extend that pattern. And we know we want to put the application at the heart of it. We want to put our data product at the heart of it so that people can define it themselves. And so we created our own design principles off the back of this and decided what we wanted to be able to build into. So we wanted to invest into creating the most frequently needed resources first. So we have a set of core things that almost every data product has. So we started there. We want to center our creation of our infrastructure as code around the function that something is doing rather than the technology that it is using. So we have input ports that go from queues into storage, not necessarily from SQS to S3, although that is what it's doing. We don't necessarily describe it in that way because we want to be able to switch out things without it having massive knock-on effects every time we make changes. We wanted it to be based on an automated deployment. So that was going to be key. If we're going to scale and have 300 data products, I don't want to press 300 different buttons every time we need to roll out a change in order to trigger deployments everywhere. And I definitely don't want to have to be doing that manually from my laptop. We wanted to provide those product teams who are creating data products with autonomy and independence. We wanted them to be able to crack on and not even need to talk to us in order to create their data products. We want them to be able to fulfill all of the business requirements that they're having thrown at them without having to kind of come to us for permission to do anything, for the need to do anything. And really the only need that should be there is if they're doing something that's really new. And then, yes, we'll work collaboratively together to build that into the existing patterns, and then it's there for everyone to use going forwards. And of course, yeah, we wanted them to be able to move quickly and create their data products themselves and manage them on an ongoing basis as well. So updates and things like that, changes in how they wanted to structure their data products, permissions changes they wanted to make, to be able to do all of that stuff without any involvement from us. And in particular, without any fear that they might break compliance or security standards. So a lot of what we're doing with our self-service as well is providing them with guardrails so that they can't go wrong or can't go so drastically wrong. That's our real aim, is to provide them a safe environment to work quickly. So how did we get to where we're going or where we are? In here, we're looking at, as we started as kind of one team, and there was a lot of collaboration between product and platform, product being kind of the team that's creating our data products. We built only what was required. There was a lot of manual testing. The first data product took about 3 weeks to build overall. And that was fine. You know, we learned a lot doing that with them. But then we wanted to spot what our patterns were once we've got started. Okay, so once we've got 1 or 2 data products, we can start to see what are the core fundamentals. So what are those frequently used components? And we started pulling those out, putting those into shared Terraform modules. So we're using Terraform to do everything here. And we're pulling those modules out using Terraform. We've got some pipelines starting to appear. We're testing them. So we've got kind of static analysis and something called checkoff, which does a lot of kind of security-esque checks for us. So it checks if we're not using the resources in Terraform in an expected way. So it might query us if we try to create a bucket without putting any block for public access on it, for instance. And the other thing that we started to build in there as well is little policy checks of our own. So for instance, for us, it's quite important that everything gets tagged correctly, because when we come down the line and we want to start thinking about, well, how much is everything costing? We need to have everything tagged correctly. So we started applying little policies to check that everything was being tagged correctly and kind of building up from there. So once we've got our policies and some of these things in place and we start putting things in our pipelines, well, now it takes like less than a day to make a data product, particularly if it's one of those standard ones. If you're doing something new, we'd still need to build something new. But for our core data products, it's now taking less than a day. We start looking up at our control logic, and we start going down to like half a day. We start pulling in more component thinking about that function over everything else, like I was talking about. And then where we are at the moment, we're kind of iteratively working through that magic YAML phase. So we're putting the control completely in the hands of the product teams. And then it comes down to taking an hour to make a data product. So now it's taking a lot less time. But what we're also doing, and what you might see in the pattern here, is we're evolving the testing practices and our automation testing alongside each of these maturity upskill points. So, you know, we had manual testing, then we had some basic validation and some tools to help us check. Then we started building end-to-end and some functional testing. And now we're going really heavily into that testing, into that end-to-end, into functional testing, into what I'm going to call in here like mini stacks, which I will explain a little bit more in a minute. And in the future, we're also building into ML data products as well. So how do we structure that, which is, I think, the interesting thing here? Well, we've looked at different tools. As I said, we're using Terraform a lot. Terraform has always been the default at ITV. It's a pretty standard default in infrastructure more broadly. So obviously we wanted to start from there, and we wanted to kind of leverage a lot of the existing stuff that was available. But we kind of built in then and went, okay, so now that we're thinking about how we structure our capabilities, our way of putting these modules together in order to give us what we need with our self-service, well, Terraform is not a great place for logic. It's very difficult to test logic in Terraform. At least that's my personal opinion. And so we decided we needed somewhere else to do that, really. And we looked at a number of different things that we could do with our tooling and what we were using to build the infrastructure. And we decided we still wanted to keep a certain layers of Terraform because that's used widely throughout ITV, and so it enables us to kind of play with other departments and other teams quite well. And B, it is good and it's solid and it's mature. And we know what we've got, and we already had a lot of things already in Terraform. But we decided to create this kind of wrapper layer. And our wrapper layer was the thing that was going to ingest that magic YAML and turn it into some Terraform modules. And we looked at a couple of different things. We looked at the CDK Terraform, which is ultimately what we went for. But we also looked at, could we convert everything into Pulumi, or maybe we should just do everything in Terraform, or even rewrite everything in Python ourselves. And there were a few options, but for us, CDKTF really was the obvious one that gave us that trade-off between the Terraform modules that we could keep and we could swap with other departments who weren't using CDKTF, and also gave us a place to put our logic that was way more testable. So now we can, create that thin wrapper Python layer with little tests in there, being able to test the modules and test the way we're combining the modules together. Because the big thing here is that, we can have so many different combinations of inputs and outputs and computes that there are a lot of different permutations. So we have to be really careful with the way that we're connecting these modules together, with the way that we are basically creating a set of variables within that wrapper layer, so that we can harmonize and get the right things out of the modules and pass the right things back into other modules. It also means that whilst we really want everybody to come in on that top kind of main users arrow and use our logic wrapper and submit their magic YAML to us, or to the pipelines in order to create their data products, there is a way for more experienced, more technical users to come in at a lower level if the need arises, to do their own combinations if they need to create data products outside of the main domain stacks that we've got. So it gives us a little bit of flexibility there as well. But, carrot and the stick, our aim is just to make this as painless as possible so people want to use it. Okay. So if I break things down a little bit more again, so when we're talking about our mini stacks, as I said, testing is really key for us. And the way that we want to do this is it is so reliant on us having really solid, really good testing practices. So we've got our logic layer, which is in Python, which is on the CDKTF. So we can define kind of normal kind of Python unit testing frameworks in there. We've got our Terraform kind of modules where we're able to use TerraTest, and we have a bunch of TerraTest tests. But we also have this kind of concept of a mini stack, which is not a whole data product stack. It's a sort of part of it that maybe is frequently coupled together. And we get to be able to test those pieces as well, because they're so intrinsically linked together that we choose to kind of test them together as well, even though we kind of write them separately because the configuration can be a little bit different. And so that's also been a really nice way for us to kind of manage our testing and do some smaller kind of testing before we get all the way to this end-to-end testing, and not have to rely on waiting until we get to end-to-end testing for things to fail. It's been a way for us to help look at how do we push things to the left, as we say. So push our testing to the left, fail earlier if things are going wrong, if things aren't. We're making a change so that things don't connect with one another quite so simply anymore. And that's been really important for us. So as I said, we're using TerraTest here, we're using PyTest. For our end-to-end tests, we're using our own Python testing and Bot3 and calling APIs, because for us in our end-to-end testing, we don't just want to test the modules and the wrapper themselves, but the entire deployment process. So we get to deploy the data product as a product team would, tear it down again at the end. But then when we test that, we're really seeing what's going on and is that whole deployment process working and capturing any errors in that as well. So what does it look like? How do we actually push this through a pipeline? Well, it is tricky. I'm not going to lie. We have our Terraform modules, and they go through a number of those testing stages that I was talking about, and we version each of those independently. We also have our wrapper, and our wrapper kind of runs its unit tests and sort of versions itself as well at that point, but we version with the modules in the wrapper. So they kind of come together, the new versions of our modules, the new versions of our wrapper. We kind of stamp that as one release that the product teams can then use. We go through our testing, obviously, end to end with that before we release it to them. And then our product teams are free to pick up that latest release and use any functionality improvements and other things that are in there and tie it into their pipeline. And so they then become responsible for that, which is kind of good. For us, it means we don't have to worry about it, but also for them, it means that they can time when they want to do those infrastructure updates so that they happen at the same time as relevant data updates with their own products. There's a few things that I'm oversimplifying here in this diagram. I'm not going to lie. So there are things that we struggle with, right? So Terraform migrations are always a big one. So, what happens if you need to make some sort of migration script that you need to run? Well, we have some thoughts about how we might push that into the pipelines and how we might manage that. But it's definitely one that is a difficulty to manage sometimes, particularly when we're trying to push it to teams that don't need to know about Terraform very well for them to implement and apply themselves. It's a little bit tricky. So we do obviously just try to make our Terraform modules so that they don't, change state very much, so that they are more stable. But we can't guarantee that. I mean, AWS recently pulled apart the bucket module and put, versioning and other things separately. So, there are upgrades with providers that are out of our control that we have to be able to accommodate for. And also, as I said, there's just so many permutations that we don't test every single permutation. We try our best to cover our bases and to do things, particularly in that end-to-end testing, that kind of incorporate most of the modules where we can. But it's very difficult to know exactly how the product teams are necessarily going to use your modules. I had something only this week where one of the teams came to me and said, "Oh, can we include another one of these in here?" And they were using one of the modules in a way that we hadn't quite expected them to use it. Well, that's fine. We evolved. We adapted to that. And really, that's why we just have to make sure that our setup and the way that we're producing this is kind of adaptable to those standards. And just a final kind of what does it look like here? I guess I will just kind of click through a bit of a very oversimplified mock-up of the simplest type of a data product that you could get. But maybe you have a magic YAML that looks something a little bit like this, saying that you have input from another data product. So you're taking the output of another data product as your input. You're then outputting whatever you turn that into. Maybe you're doing some aggregation into your own table as an output that certain user groups are allowed access to, and you're doing that on the back of Databricks. And as I was saying, so there's a couple of clicks involved. So you've got to do your click to submit that, to do a git commit. You're going to run a Jenkins pipeline, and then you're going to have your infrastructure. And that's going to be set up ready for you to then run the Spark code, the kind of data product code on Databricks, submitting that job and creating that output. And you know, this is where we're kind of getting to our click. Hopefully there's not that many clicks for them. We've kind of streamlined the architecture and the infrastructure so that they can talk about it in those 4 groups. So you can see down the right hand side, we've got some of the kind of metrics and things, which are our control ports that we're not really specifying in our YAML, but we're getting. And then we're getting our inputs through our permissions in the bottom left, and our outputs through the Databricks configuration and our bucket policies in the kind of middle and top there. So with that, I'm gonna, I think, hand back to Clemence, because I know we're a bit tight on time. Otherwise, I could probably talk about data products and go into all the details for the rest of the day. Yeah, and if anybody does want to talk lots and lots of details another time, I'm sure we can do that another time. But yeah, Clemence, I hand back to you to talk about what we're going to next.
Yes, thank you. And she can talk about data product all day. I can confirm that. So part of my role at ITVs is to set a vision. So the first part that Lou went through, it was the vision from a couple months ago, I would say. And now we're looking at what's going to be next. So there's in my mind, there's 2 things. So one is how do we incorporate machine learning into those data products? What does it look like? What's how do we create a new flavor of data product? How do we make sure that it's not a square peg in a round hole kind of thing, kind of situation we want to avoid? So because there's the training, there's the deployment of the models, there's the feature building, etc. So there's a lot of complexity that comes with those type of discipline, and so that's something we're looking into at the moment. And the next one, which is what I'm very excited about, and weirdly enough, the platform team is a lot less excited about, it's what I call oversight. It is all about visibility. I always put myself as a technical user, I am very happy to look at YAML file and to look at code and to look at Terraform and to look at architecture, and I enjoy that tremendously. But I'm also very conscious that my stakeholder don't look at it the same way. And to be able to really talk about the platform, which sometimes is intangible and seems very far away to people and complex to people, that they can't really go to it and really understand it, there's a way for it in terms of creating something that we call oversight to make it clearer to people. So it's all about, okay, cost, how much the data product cost? Is there data products that are more expensive than others? In terms of domain, what's the cost of the platform per domain? Is there things that we can optimize, etc.? And looking at reliability, how reliable are we? Are we good at deploying stuff? Do we have stuff that fail? Do we have stuff that take too long, etc., etc.? There's all part around developer experience. How good is the experience? Is there blockage somewhere? Is there things that are taking a long time? Is the feedback loop to create those data products very long and actually creates more bottleneck than anything else? If we can have a view on that and we can get KPI and benchmark, then we get better at it as well. And the last one is the compliance aspect of it. The data mesh, one of the concepts is to create like a bit of a federated governance. Well, how do we present that back to the business and say, okay, here's all the dashboards that we can tell you, here's all the retention we have, here's where the ownership of data products is, etc. And all of that is really about using our own data product to ingest our own data and creating data product about it. So it's cannibalizing ourselves to some extent, but it's a very nice use of our own infrastructure to do that. So I'm very excited about this one. So those are kind of the 2 big things that we have.
Thank you, Clemence and Lou. That was really an exciting talk. We have a question. How did the introduction of the data mesh changes the team structures, typologies? Did you have to introduce data roles to the product development teams?
So I'll take this one. So with the data mesh come the full operating model. It is quite drastically different than what was at ITV before. Well, I joined with the data mesh as part of that new thing. So for me, it was, coming in and taking care of, because I take care of all the tech, was taking care of the platform team, data engineering, data science and machine learning team. It was kind of like, okay, how am I going to structure my team so it feels adequate to go with the mesh? But it was something completely different than was at ITV before. There was pockets of teams relatively independent, not necessarily working cross-functional team. So a lot of change and a big change in structure and operating model for sure.
Yeah, thank you for the answer, Clemence. I mean, this was a quite ambitious goal you set yourself to provide, let's say, self-services to any kind of users without having the users having the technical expertise. So when is enough when it comes to maturing and automation and dropping of self-services? Maybe that question goes to Lou, I don't know, or to both of them.
Yeah, no, so we talked about this a bit, particularly when we're setting the vision, right? Because we could go to a UI, right? We could have everybody click the things in a UI, maybe in a developer portal of some description. And for us, that might be too far. So we have to kind of balance, I think, where the effort and the value that we're retrieving out of that kind of that scales weighs in our favor. For some people, they might look at this and think, well, the CDKTF layer, that wrapper layer feels like too much. Surely, if you just have functional Terraform components, that's enough. And in some places, that might be true. We chose to go an extra step further with that wrapper layer because we want to go out to data scientists, to kind of business analysts, to people who are a little techie, but technical, but not a techie, perhaps. As I often say, you can be tech. If you work in tech, you're probably technical, but you might not be a coder, you might not be a techie. So we wanted to provide that layer for them. And it is one that we balance, and I didn't get a chance to go into it so much in the talk, but like about how we balance that with the product teams and the people who are more technical and are being made to use a less technical solution. And the kind of balance that we play with them in how we get them to use it and how we collaborate with them. To make sure that, one of those things that we're not slowing them down, that we're keeping them to be able to move fast. So I think it really comes down to individual organizations and individual goals and really who your self-service users are, and making sure that you understand them and understand the reality of how far you might have to go. Maybe one day ITV will go to a clickable interface. I don't know that this on its own will be enough of a driver to do that, but there are certainly conversations about combining it with other drivers across the business, which might lead to that in the future. But that's probably a way down the line. For now, we think even our non-technical technical people, the YAML is probably sufficient. It's just that the way that we write that YAML is we try and group it into those 4 sections so that we make it as understandable as possible. But yeah, we extract some of that complexity.